Hello students, welcome you to this video. Already probability we studied almost all the results, right? Addition theorem on probability, then conditional probability, independent events, mutually exclusive events, right? So in this video we are going to study just two formula. One is how to find total probability, another one how to use Bayes theorem. Okay, just like explain the two formula, then we do the sums, you can understand better. Okay, so now let us see what is total probability. A1, A2, A3, etc. An are mutually exclusive and exhaustive ones. See, what are mutually exclusive? You know, mutually exclusive means nothing is common, right? When you take, suppose I'm considering two events, A and B are two events, and S is the sample space. A intersection B, when you find A intersection B, you have to get empty set, then you say they are mutually exclusive. Exhaustive means when you take the union, A union B, you have to get the entire sample space, yes, okay. So, but here, what is given? Two events, the events are mutually exclusive and exhaustive. How it is possible? See, this is yes, mutually exclusive and exhaustive means it should be something like this. A is one event, B is another event, right? Nothing is common, no? When you take intersection, nothing is there. But when you take union, you are getting sample space. But if you draw our usual diagram, two circles like this, they are mutually exclusive, nothing is common, but when you take union, you won't get sample space, many space left out, right? So, mutually exclusive and exhaustive, we say they form a partition. See, the sample space, there is a partition here, right? So, here its extension, A1, A2, A3, etc., An are mutually exclusive and exhaustive events, and B is any event in S, then P of B is called the total probability of event B. And the formula is P of B is equal to P of A1 into P of B given A1 plus P of A2 into P of B given A2 plus P of B3 into P of B given A3, P of A3 into P of B given A3, and so on. Okay, depends on how many A1s are there, A1, A2, A3, A4, right? So this gives total probability. And Bayes theorem, again the initial conditions are same, A1, A2, A3, etc. An are mutually exclusive and exhaustive events. Then P of AI given B. Denominator is the total probability. What we have seen now, the same formula. Numerator depends on this numerator. If it is A1, you write the first term, P of A1 into P of B given A1. If it is P of A2 given B, denominator remains same, but the numerator you write P of A2 into P of B given A2. Okay, so that is Bayes theorem. So when you do the sum, you can understand better. It's a very, very simple thing. Only the question looks little lengthy one. So read the question carefully, just to form a tabular column, what is given, then you can do it very easily. A factory has two machines, M1, machine 1, machine 2. I'm taking M1 as machine 1. And M2 is machine 2. Machine 1 and machine 2. Okay. Machine 1 produces 60% of item and machine 2 produces 40% of items, right? M1 and M2. The production given. Machine 1 produces 60%, right? 60%, so 60 by 100, and machine 2 produces the balance, that is 40%. Now see what else given here. Further, 2% of item produced by machine 1 are defective. So this is another event. So I'm taking, let A be defective. Defective item. Okay. Machine 1 produces, machine 2% of item produced by machine 1 are defective, 4% produced by machine 2 are defective. So next, defective. So machine 1 produces 2% defective. So 2 by 100, machine 2, 4%. Okay, the items produced by machine 2, in which 4% are defective, machine 1 produced until there are 2% are defective. See what they asked. If an item is drawn at random, what is the probability that it is defective? What is the probability that it is defective? We have to find probability of getting a defective item. Probability of getting a defective item. That is, you have to find P of A, total probability. Defective item is produced by which machine? Machine 1 or machine 2? Both the machine produces defective items, right? So there are two possibilities. Select the first machine and that select first machine produces defective item. R means, you have to put plus. Second machine and that second machine produces defective item. Please listen. Selecting the first machine, P of M1, and now the first machine is selected, right? It gives a defective item, P of A given M1. Or, same way, right, for M2. Select the second machine, P of M2, into, now the second machine is given, which produces defective. Defective I taken as A, right? Machine 1, item produced by machine 1 is 60%, 60 by 100. And first machine produces defective, 2%, 2 by 100. Plus machine 2, P of M2, 40%, 40 by 100. Defective, 4%, 4 by 100. Calculation part, please listen. So 0, 0 you cancel. Here also 0, 0. Same number you cancel in both the cases. So LCM will be easy. You can cancel by 2 table and all. I'm not doing that. So 6 2s are 12 by 10 into 100,000. Plus 4 4s are 16 by 1000, right? If you add it, you are getting 28 by 1000. Dividing by 1000, right? 3 digit you shift to the left, 3 digit you shift to the left. So what you get? 0.028. You can cancel by 4 table also, but this is a easy calculation, right? So hope you understood. Now let's move on to the second question. Listen, this is a 5-mark question. There are two identical urns. So I'm taking urns U1. It's a bag. So urn 1. And 1 and U2. If it is bag, you write B1, B2, B3 like that. Here there are two urns, and 1 and 2. There are two urns. Respectively, the first urn contains 6 black, 4 red. 6 black and 4 red in the first urn. So U1 contains, and urn 2 contains, see what is given. 2 black, 2 red. 2 black and 2 red. An urn is chosen at random and a ball is drawn from it. Find the probability that it is the black ball. So next event, let A denote black chosen and a ball is drawn, black ball. Okay, now there are two subdivisions. See the first part, what they asked. First subdivision is find the probability that the ball is black. Probability that the ball is black. We are taken as A, so you find P of A, that is the total probability. Black ball is in which urn? Both the urns contains black ball. So there are two possibilities. Select the first bag, draw a black ball. Or select the second one, draw a black. Selecting the first urn, P of U1, and from the selected first turn, you draw a black. So that is taken as A. Or, so put plus. Same way, select the second urn, P of U2. Now the second urn, you got it. From that, you draw a black, P of A given U2. There are two bags or two urns, the equal, identical urns, right? So the chances of selecting each one is 1 by 2. Suppose there are 3 bags, then for each the probability is 1 by 3, 1 by 3, 1 by 3. The previous one, machine 1, machine 2, 2 machines. If they are equal efficient, then 1 by 2, 1 by 2 only. But one first machine produces 60%, second one produces 40%, so they're not equal, right? Suppose 50%, 50% means 50 by 100, cancel 1 by 2, 1 by 2, right? But two machines of different efficiency. Okay, so that's why it's different. But here, two urns, two identical urns. So selection, the probability of selecting the urns are equal. Since there are two urns, 1 by 2, 1 by 2. If there are 3, 1 by 3, 1 by 3, 1 by 3. If there are 7, for each one probability is what? 1 by 7. Now P of U1 is 1 by 2. First urn containing black ball, totally 10. Favorable black, it is 6, so 6 by 10. Plus P of U2 is again 1 by 2. So from the second one getting a black, it is 2 by 4, right? So now denominators are different. So just to cancel and do 2 table, you cancel 3. So first one 3 by 10 plus second one 2 and to cancel, you are getting 1 by 4. So take LCM as 20. In 20 by 10, 2, 2 3s are 6. 28 by 4, 5 into 1, 5. So your answer is 11 by 20. So this is the answer for first part. There is one more subdivision. It's a 5-mark question. Listen. Second subdivision, if the ball is black, it is a condition. If the ball is black, so black ball is given, that is A. If the ball is black, what is the probability that it is from the first turn? If they ask what is the probability it is from the first turn, you write U1. If they ask what's the probability it is from the second turn, numerator you write what? U2. Okay? It is given a black ball is drawn. Bayes theorem we have to use. Denominator you write the total probability, that is selecting the first turn, and from the first turn you are drawing a black. Or select the second turn, and from the selected second turn you draw a black. Okay? Numerator, if it is U1, write the first term. If it is U2, instead of U1, if it is U2, write the second term. Okay, the numerator, that's what you have to do. Among these two, you are going to write 1. Which one? Depends on this. Here it is U1, write the first one. P of U1 into P of A given U1. P of U1 is 1 by 2. P of A given U1 means getting a black from the first 6 by 10, right? It is 6 by 10. Denominator total probability, already got it. It is what? 11 by 20. So denominator is 11 by 20. So 2 table you cancel, you are getting 3. So you are getting 3 by 10 divided by 11 by 20. You write into 20 by 11. 1 0 cancel. So your answer is 6 by 11. Okay, hope you understood this. Okay, now let's move on to the next question. It looks very lengthy one, right? But it's a very simple thing. Just read it, try to understand what is given and what they asked to find. Okay, so a firm produces PVC pipes of 3 plants X, Y, Z. The daily production from the 3 firms X, Y, Z are respectively. So X, Y, Z. The production given. So first turn produces 2000 units, second one 3000 units, third one 5000 units. So the total production in, total production is, first it is what, 10,000, right? Okay. Now please listen what else given. It is known from the past experience that 3% of the output from plant A, 3%, 3 by 100, plant X, right? 3% by plant X, then 2%, 4% from plant Y, 4 by 100, and 2% from plant Z are defective. Okay, defective. A pipe is selected at random from a day's total production. Okay, now first we give some letters. So X, Y, Z, that are the 3 plants. We take X, Y, Z itself. And the defective one I'm taking as A. Let A stands for defective. Defective pipe. Now see the first subdivision. See what they asked in the first one. Find the probability that the selected pipe is a defective one. Probability of defective pipe. That is, you have to find P of A. Total probability defective pipe is produced by all the 3 plants. There are 3 possibilities. Select X plant produces defective, or select second which produces defective, or select Z which produces defective. Selecting the first plant, that is selecting X, and that X is producing defective, or selecting the second plant Y, and that second plant produces defective, or selecting the third plant Z, and that selected third plant produces defective. Now look here, the efficiency not same. Otherwise, 3 plants, you take it as 1 by 3, 1 by 3, 1 by 3. But here not like that. So first one produces 2000 out of 10,000. So P of X is 2000 by 10,000. And which produces defective, that is what, 3 by 100. Second one, P of Y, second plant produces 3,000 pipes. So 3,000 out of 10,000. And which produces defective is 4%, 4 by 100. Plus P of Z is 5,000 units, right? 5,000 by 10,000. And in which the defective 2%, 2 by 100. So you have to simplify this. So you cancel 3 zeros alone, I am cancelling. Here 3 zeros. Here also 3 zeros I am cancelling. So the remaining you simplify, 3 2s are 6 by 1000, right? Plus 3 4s are 12 by 1000. Plus 5 2s are 10 by 1000. So 1000 LCM. 6 plus 12, 18 plus 10. So it is 28 by 1000. You can write 0.028. But one more subdivision is there. This total probability we are going to write in the denominator. The denominator, if we get some decimal, then the calculation will be not easy, right? So what I'm going to do, you can write either 0.028 or you can write it as cancel by 4 tables. 7 4s are 28 by 250. Okay, you can write any one of these. All these 3 are same only, right? Any one of this form you can write your answer. Now see the second subdivision. See what they asked in the second one. If the selected pipe is defective, it is a given condition. If the selected pipe is defective, it is defective given. Then what question they can ask? What's the probability it has produced by plant X or plant Y or plant Z? Among that 3 they ask anyone. What do you do? Denominator, the total probability, you write everything. If the plant X means you write the first term in the numerator, plant Y, second term in the numerator, plant Z means write the third term in the numerator, right? But let us see what they asked here. What is the probability that it was produced by plant Y, right? So P of Y given A. So denominator you write total probability, selecting the first plant, and P of A given X, or selecting the second plant and which produces defective, or selecting the third plant and that one produces defective. Numerator, since Y is there, you write the second term in the numerator, P of Y into P of A given Y. Listen carefully how to write P of Y into P of A means the second term, right? Second term, this is your answer, but anyhow you write the steps. 3000 by 10,000. 3000 by 10,000. That's the production P of Y into which gives a defective one, second one, right? 4 by 100. 4 by 100. Divided by total probability, already got it. I'm going to write this one, 28 by 1000, so that the calculation will be easy. Okay. So what we do here, cancel 3 zeros. So first one is 3000 by 10,000. Yes. Okay. Cancel 3 zeros. So you are getting 3 4s are 12 by 1000. By 28 by 1000, you write 1000 by 28. So 1000 cancel. Now you cancel by 4 table. 3 4s are 12, 7, right? 7 4s are 28, right? So your answer is 3 by 7. So calculation, so do in such a way so that it is very, very easy one. Okay, now let's move on to the fourth question. The chances of A, B, C becoming manager of a certain company are 5:3:2. So A, B, C. There are 3 people. The chances of becoming a manager, the chances are 5:3:2. So the total ratio is 10, right? Total ratio is 10. So what is the probability of A becoming a manager? Total ratio is 10. A is favorable 5. So 5 by 10. Or you can say 1 by 2. Probability that B become a manager is 3 by 10. Probability that C become a manager is 2 by 10. The chances are not equal. If the chances are equal for every person, it should be 1 by 3, 1 by 3, 1 by 3, right? But here, the chances are 5:3:2. So you have to take in this way. Now, probabilities that the office canteen will be improved. So this is another event, okay? Canteen improved. So for that we give a name. Normally we give A, but here already A, B, C are 3 managers, right? So we give some other letters. Say I'm taking as X. X is what? Canteen improved. So this is an event, okay? So A become manager and the canteen is improved. The probability they given us 0.4. B become a manager, then the what? The canteen improved 0.5, and C improves the canteen. The probability is what? 0.3. Now please listen what they asked here. Only one subpart here. If the office canteen is improved, given condition. So probability that the canteen is improved, that is X given, right? What is the probability that B was appointed as manager? Like previous question only. Y, second one, right? But here B, yes. Denominator, you write total probability. What are the 3 cases? A becoming manager, and now A is a manager, improves the canteen. P of X given A. Or B become manager, and that person improves the canteen. Or C become the manager and that C improves the canteen. Numerator among these 3, 1. Which one? Here B. So write the second term. So P of B into P of X given B. Okay, that's all. P of B. What is P of B? 3 by 10, right? So 3 by 10 into B improves canteen is what? 0.5. 0.5 means 5 by 10. So if you want, you can write that first itself, right? P of A. P of A is equal to improved, right? P of X given A. A become manager and it's improved. 0.4, you can write 4 by 10. Same way, P of X given B. B become manager and improves the canteen 0.5, so it is 5 by 10. And P of X given X given C. It is 0.3, you can write 3 by 10. So the calculation will be easy. Denominator P of A. A becoming manager is what? 5 by 10. And improves the canteen is P of X given A, 4 by 10. Plus second one already in the numerator written, 3 by 10 into 5 by 10. And the last one, P of C. P of C is 2 by 10. The improves the canteen is 3 by 10. 2 by 10, 3 by 10. 2 by 10 into 3 by 10. So I'm not cancelling anything. 5 3s are 15 by 10 into 10, 100. Here denominators 10 into 10, 10 into 10, 10 into 10. So 100 is LCM. 5 4s are 20. Plus 5 3s are 15. 2 3s are 6. So 15 by 100 divided by, if you add all these things, you are getting 41 by 100, right? So it is 15 by 100 into 100 by 41. So 100 cancel. So your answer is 15 by 41. That is your final answer, okay? So just 2 things, total probability and Bayes theorem. Okay, like this, you practice more questions. We'll continue in the next video.